Okay, so looking at number 9 is asking us to solve the equation on the interval 0 to 2 pi, and it wants us to solve this equation, sine 2 theta equals cosine theta. And so we're going to use our double angle formulas, and then we're also going to need our unit circle for this particular problem. So let's go ahead and commence solving. All right, so where to begin? So looking at our double angle formula, I see that I can change sine 2 theta. Okay, I'm going to use my formula and do 2 sine theta times cosine theta equals cosine theta. All right, so the next thing I want to do, because I am solving, right? If you remember in your back a few chapters ago or last year, when we were solving for polynomials, we wanted everything on one side of the equation because we wanted to find the zeros of the equation. So likewise with this, we're going to move cosine over to this side. So we'll have 2 sine theta times cosine theta minus cosine theta equals 0. Now, what we can do here, you'll notice that I have a term that they have in common, so I can factor that out. I can have cosine theta times 2 sine theta minus 1 equals 0. And so now I can find the zeros of these two terms. So I can find the zeros of cosine theta and of 2 sine theta minus 1. So for cosine theta, well, cosine theta can equal 0. That one's easy. And then let me do it in a different color for sine. So do it in gold. 2 sine theta minus 1, to zero this out, we'll end up with 2 sine theta equals 1. And then finally sine theta equals 1 over 2. So now if I look at my unit circle, I want to find the areas where cosine theta will equal 0 and sine theta will equal half. So with cosine, I'm going to do this let's do this in red. So the areas where cosine theta will be 0, okay, so that means the x will be 0. That's going to be pi over 2 and 3 pi over 2. That's the only two spots where cosine theta will be 0. Now, how about sine theta? Now, sine theta, that's the y. So that means I'm going to just look at the top half. I'm going to look from 0 to pi, right? Because y is positive, so I need to look at where the y's are positive. So where is sine theta positive? And it is positive a half, is a positive half at pi 6 and 5 pi over 6. And so on the interval of 0 to 2 pi, and solving for this particular equation here, I find that these are my zeros, my solutions to this particular problem. Okay, so let's work now on number 11. So looking at number 11, it's asking us to solve cosine 2 theta minus sine theta equals 0. Well, okay, so cosine 2 theta I know has an identity, so I can pick any one that I want. I'm going to go ahead and pick one that has sine in it, just to make it a little easier for myself. So I'm going to pick the bottom one. So cosine 2 theta will be 1 minus 2 sine squared theta minus sine theta equals 0. So going from here, let's see here, 2 sine theta minus 1. So one of the things that I can do here, I'm going to do a little trickery here, but this is going to make it easier for myself. I'm going to extract from all of these terms, I'm going to extract a negative 1. So what that's going to do, that's going to flip the signs of all of these. That'll make this a negative 1 plus plus. And so now I can rewrite this, and I didn't have to do this, but it's just going to make it easier for me. I can rewrite this as 2 sine squared theta, that's positive, right? Plus sine theta minus 1. So what that does, that actually is going to make it just a little bit easier for me to factor this out now. right? So I'll know that I'll have a negative 1 on one and a positive 1 on the other because of this term. And then I have a 2 sign. So one of them will be a 2 sign. Now keep in mind here that I have a positive sign, so that means this 2 sign here, you want it to be positive. So you don't want it over here, because then I'm going to have a negative 2 sign, and then plus a positive sign. That should give me a negative. So I don't want it over here. I want it on this side. I want a 2 sign theta here, and then I want the sine theta here. And just so you can see what I was talking about, let's work this out. So if I distribute this term to this term here, right, I end up with a 2 sine squared theta, check, right? And I end up with a minus sine theta, all right? But then when I distribute this term to both of them, I end up with a plus 2 sine theta minus 1. So you see how this plus 2 sine theta minus this 1 sine theta will give me a positive sine theta? And that's what I have right here, right? So that's why I wanted this sine theta next to the negative. That way I can end up with that positive sine theta, okay? And you know, that may not have been obvious right off the bat, but once you checked your work, you would have seen that you would have had a negative sine theta, so then you would have had to flip it. So either way, so let's continue on. So similar to the previous problem, I want to find the zeros for both of these. Okay, so I'll find this one in green. So sine theta plus 1 equals 0. So that means sine theta is going to equal negative 1. And then in blue, 2 sine theta minus 1 equals 0. So that's going to be 2 sine theta equals 1. So sine theta will equal 1 over 2. So these are the two terms that I have. And I want to find out where sine theta will equal negative 1 and where sine theta will equal positive half. So sine theta will equal a negative 1 at 3 pi over 2. So the y will equal negative 1 at 3 pi over 2. And that's the only place. That's it. And so now I'm going to look over here for the sine. So where will sine be a positive half? And I actually know that from the previous problem, pi over 6 and 5 pi over 6. Okay, so those are my solutions to this particular problem, number 11. All right, let's continue.